Hi everyone, today is Somerset MO Club Lecture 9. Today we'll talk about geometry and statistics. Part 1, Geometry. A very important part of today's lecture is about the Pythagorean theorem. What is this theorem about? The Pythagorean theorem basically focus on one type of triangle, like we show here. This triangle has a very important property, that is one of the three internal angle is a right angle, which is 90 degrees. For this type of triangle, they have a very important property. The long side, which is called hypotenuse, denoted by C here, the C square would equals to the sum of leg 1 and leg 2 squares, which is a squared plus b squared. For higher grade students, you can look up online why this is. For lower grade students, will have to remember the long side hypotenuse square equals to the sum of the squares of the two other legs. Question number 1. Four identical right triangles with legs A and B are attached to sides of square WXYZ as shown, such that PW equals to QX equals to RY equals to SZ equals to A, and PX equals to QY equals to RZ equals to RW equals to B instead of number 4. Question number 1. Explain why angle PWS is 180 degrees and why PQRS is a square. Okay, first of all, this PWS is one straight line. As we mentioned before, one straight line is 180 degrees. But now we can actually figure this out. Since this is a right triangle, so this is 90 degrees. This angle, PWX plus the second angle, which is PXW, equals to 90 degrees. Since all triangles are identical, okay, so this angle plus this angle, which is the same as this angle, is 90 degrees as well. So PWX plus angle SWZ equals to 90 degrees. And this total angle PWS equals to the sum of these two angles and plus this angle. So what is this angle? So four identical triangles, they all have the same long side, right? So therefore, the inside has four equal sides. And this equals to 90. So this is a 90 degrees as well. So inside is a square. So therefore, this is 90 degrees. So plus a 90 and 90. So 180 degrees. Question number 2. What is the area of PQRS in terms of A and B? PQRS, the outside square. So the side is A plus B. Since this is a square, you multiply the same. Or just square it. For lower grade student, we can do A multiply A multiply B multiply A, B multiply B. So break up into four terms. A squared plus AB plus BA plus B squared. AB multiplied together equals to B multiply A. So we have A squared plus 2AB plus B squared. Okay, number 3. What is the area of WXYZ, the inside square? The inside square has side lengths of C. C, we know that C squared for a right angle equals to A squared plus B squared. And the area for WXYZ is C squared. So therefore, the area is A squared plus B squared. Number 3. How can we show that A squared plus B squared equals to C squared? Okay, so if we want to use the answer from part number 2 and part 3 to solve this. So if we start from part 2, the total area of the outside squares, that area, PQRS minus 4 of the small triangles would equals to the area of the inside squares, right? So since the triangles are the same, we just use 1. So PXW. So this is PQRS square. The area is a squared plus 2ab plus b squared minus 4 times of the triangle area. That is 1/2. The base is a and the height is b. So the student can carry this out. This would eventually give you an answer of a squared plus b squared. And that's the area for the inside area of c squared. Question number 2. Find the missing side length in each of the 3 triangles shown below. Okay, for the first triangle, for example, this one, we know the long side and we know one of the leg and we need to find the other leg. So basically, we want to continue using the equation of c squared, which is the long side, equals to the squares of the other 2 legs. So now that you know the long legs, and one of them is 5 squared plus b squared. B is the number that you need to find out. So 8 squared is 64 equals to 25 plus b squared. Therefore, b squared equals to 64 minus 25. So b would equals to the square root of 939. Okay, and we will leave the other 2 triangles for students to figure out. Basically, you just keep using this property. The long side squares equals to the sum of the other legs squares. Question number 3. Part 1. Must the hypotenuse of a right triangle be the longest side of the triangle? Why or why not? The answer is yes. So let's look at c squared equals to a squared plus b squared. Since they are all lengths, right? So they are all positive numbers. So a positive number add to another positive number equals to c squared. So therefore, c has to be greater than each part. Therefore, c has to be greater than a, and c has to be greater than b. So the answer is yes. Part 2. Can you find right triangles in which all these three side lengths are integers? So here there's an example. 3 squares plus 4 squared equals to 9 plus 16 equals to 25. 25 is 5 squared. So therefore, 3, 4, 5 is one of them. We can easily find many more of these. So we can have multiples of 3, 4, 5 to satisfy the same rule. So if we have 2 times of 3, 2 times of 4, and 2 times of 5. Let's double check whether this rule is satisfied. So the hypotenuse is now 10. 10 squared equals to 6 squared plus 8 squared. So 36 plus 64 equals to 100. So yes. Part B. Find the hypotenuse of a right angle whose legs are 3 multiplied 4 and 4 multiplied 4. So as we see here, instead of you have 2 times, multiples of 2, now you have multiples of 4. So you can easily guess the hypotenuse is 5 multiplied 4. So let's double check whether c squared equals to a squared plus b squared is satisfied. So 20 squared equals to 400 equals to 3 multiplied 4 is 12 squares plus 16 squares. So 12 squares 144, 16 squares is 256 equals to 400. So yes. So part C and D is basically following part B, so we'll leave for the student to figure out. Part E, find the hypotenuse of a right angle whose legs are 3 over this number and 4 over this number. So instead of a multiply, now you divide by the same number. So you can guess that the hypotenuse is 5 over the same number. Part 3. The length of one leg of a right triangle is 210, and the triangle's hypotenuse has length 750. What's the length of the other leg? So now you know the hypotenuse, you know one leg, you need to find the other one. So this question will leave for the student to figure out. Part number 2, important notes about Pythagorean theorem. If we multiply all three side lengths of a right triangle by the same positive number, then the three new side lengths are also satisfy the Pythagorean theorem, as we have seen in previous examples. In other words, if side lengths A, B, and C satisfy this relation, then n times of A, n times of B, and n times C also satisfy the same relationship. Question number 4. DEF is an isosceles triangle, which DE equals to EF equals to 26, and DF equals to 20. So part A, suppose M is on base DF such that EM is an altitude of isosceles triangle, or the height of that triangle. Why must M be the midpoint of DF? So we have to use the Pythagorean theorem to answer part A. So for part A, we have the hypotenuse here. Since we have a right angle, since this is the height, right, so it has to be perpendicular to this line. So this DE has to equal to DM squares plus EM squared. So let's write it out. DE squared equals to EM squared plus DM squared. So on this side, we have the EF squared, that's the long side, equals to EM squared plus FM squared. So now EM equals to EM, DE equals to EF, because this is an isosceles triangle. So DM has to equal to FM. Therefore, DM equal to FM, M is the midpoint. Part B. Find the area of the angle D, E, and F. Find the area. So area of a triangle is 1/2 the base, which is DF, multiplied the height, which is EM. We'll let the students figure this one out. Question 5. Suppose triangle ABC is equilateral with a side length 6. Part A, find the length of an altitude of A, B, and C. So the altitude would be AD. So as we've seen before, that the altitude is perpendicular to the line of BC for an isosceles triangle. In this case, equilateral is isosceles triangle with two equal sides. So D has to be the midpoint of this side BC. So this would be 3 and this would be 3. So then we can use the Pythagorean theorem, which is the long side minus the short side, 3 squares, equals to AD squared. So therefore, 36 minus 9 equals to AD squared. So therefore, AD equals to So part B, find the area of triangle A, B, and C. So the area of triangle A, B, and C equals to 1/2 multiply base, BC, and multiply the altitude, AD, the corresponding altitude. So 1/2 multiply BC, that's 6. AD is 3 square root of 3, which is 9 square root of 3. Okay, part C, find the angle of BAD, DAC. So basically, when D is at the midpoint, BD equals to DC, and this angle equals to each other. This side equals to each other. So everything equals. So basically, the altitude AD split the big triangle into two identical small triangles. So angle A is split in half. So each one has a half of the total, which is 60 divided by 2, which is 30 degrees. Part D, find the ratio of leg opposite to 30-degree angle. 30 degrees right here, the length opposite to this 30 degrees is BD versus leg opposite 60. This is 60 degrees. Leg opposite to that is the altitude, AD. Leg opposite 90. 90 is here. Leg opposite 90 is AB on the outside. So therefore, BD is length 3, and AD is 3 square root of 3, and AB is 6. Number 3. In an isosceles right triangle, the legs are congruent, and the hypotenuse is a square root of 2 times as long as each leg. Okay, so we can draw an example here. This is a right angle triangle. We have 2 sides that are congruent, which means the 2 sides are the same. So we need to find what's the side for the hypotenuse. So we use, again, the Pythagorean theorem equals to a squared plus a squared. So therefore, it's 2a squared. C now is square root of 2 multiply a. So therefore, the hypotenuse is the square root times of each side. Part 2, Statistics. Question 1. The table below tells us the number of students in each grade and at 4 different schools. And we have the numbers here, but we also have missing the columns, the entries are missing. So first of all, part A asks you to complete the table by filling in the missing entries. For example, you know this school, this middle school has 6, 7, 8th graders. What's the total? You can figure this one out. In this case, at this middle school, you know the total. You need to find the 8th grader students, the number, and then with knowing the other 2 grader students and student numbers. So this case is the same. You know the total, you know 8th grade, you know 6th grade, you need to find what's the 7th grade. So these are relatively easy. Part B, how many more 8th graders are there in South Middle School than in East Middle School? South Middle School and East Middle School, we need to find how many more 8th graders. So basically 339 minus 217. So all these C, D, and E are relatively easy. Students have to find out which number they're looking for in the table, then complete the relatively easy, simple operation to find the answer. We'll leave C, D, E to the students. Question 2. We asked a group of AOPS students what they think about most during history class. The results are shown in the bar chart here. So now we need to answer A, B, C, and D as true, false, or not sure. So part A. More than 3 times as many students think most about math as think most about history. So math is 50. History is about, say, 15. So 50 is more than 3 times of 15. So yes, this one, the statement is true, more than 3 times. Part B, more students think most about math than we and Rubik's Cube put together. So we is about, say, 38. Rubik's Cube is about 30. They put together is 68. But math has only 50. So this one is false. So the rest of the 2 we'll leave for the students. Basically, you have to read on the bar chart. For example, Harry Potter is just shy of 30, maybe 28. And Facebook is, say, 65. So we use all these numbers to roughly figure out which statement is true or which statement is false. Question number 3. There were 2 math teams at Beast Academy, the Little Monsters and the Bots. At the end of each day, each team graphs the total number of points it has earned. The teams use line graphs to graph their totals. Below are last week's graphs for the Little Monsters and the Bots. Describe each of the following as true, false, or not able to be determined from the graphs. So part A, the Bots had fewer points than the Little Monster at the start of Monday. So Monday is right here, and the bots is just above 100. And Monday for the Little Monster is about 300. So the bots has fewer points at the start of Monday than the Little Monster. That's true. Second part, more points than the Little Monsters at the end of Friday. At the end of Friday, the boss points is around 107, while the Little Monsters is about 340 or 350. So this is not true. At the end of Friday, the Little Monsters still have much more points than the bots. So the scale for the two teams are completely different. So the Little Monster has a very big scale from 0 to 500, while the bots has only 100 to 108. So very small scale. Part B. The bots earned more points than the Little Monsters between the start of Monday and the end of Friday. Okay, the bots has earned from Monday to Friday of about 7 points, while the Little Monsters between Monday and Friday is about 40 or 50. So this statement is false as well. The first one is false. Part C is relatively easy, so we'll go to part D and E. D, there was a weekday, not Saturday or Sunday, on which the Little Monsters didn't earn any points. So Little Monster is right here. Between Monday to Friday, is there a day that Little Monster didn't earn any points? So we can see that each division here is 100. We see a slight change here, relatively flat over Tuesday to Wednesday and Wednesday to Thursday. But the scale is so big, we cannot determine the exact number or whether it has changed from this graph. We really have to enlarge the scale to see whether there is any change. Part E, the Little Monsters earned more than 24 points on Friday. So on Friday, which is the difference between Thursday and Friday, we know the curve go up, but we don't know how much. And again, this division is 100. It's very hard to get the exact points from this kind of scale. So not able to be determined from the graph for both questions. Question number 4. The scores on a history test are shown here. And each score in the plot has its tens digit to the left of the line and its units digit to the right of the line on the same row. So the first row of the plot includes the scores 53, 57, and 59. So A, what is the average score? So average score, we have talked about this, right? We have the total, add everything up, divided by the total number. That's the average. Part B. What is the median score? Median score is, say you have 4 numbers from smallest to the biggest, and the median would be the number, for this case, would be the mean of the middle 2 numbers. If you have 5 numbers and you have the smallest to the biggest, the median will be the middle number. So the student can figure out A, B, and also C, mode score. Mode score meaning how often a number has repetitively shown itself. Part D, represent the data with a bar chart in which there is 1 bar for each tens digit. That is, 1 bar is a count of all the scores from 50 to 59. Another bar is a count of all the scores from 60 to 69. Students can choose 2 different ways of doing this bar chart. We can do this way, 50s, which meaning 50 to 59, 60s, 60 to 69, and 70s, 80s, and 90s, for example, like this. In this case, your horizontal axis would be the number of students, the number of scores in that range. For example, 50, you have 3. So this is 3. 60, you have 1, 2, 3, 4, 5 scores. You have as 5. 70, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it have to be 11. And you can continue for 80s and 90s. Part E. Can you use your bar chart in Part D to answer questions A through C, which contains more information? Your bar chart of the stem and leaf plot. Question number 5. Members of the Grosse Pie Association were asked for their favorite type of pie. The results of the poll are shown here. Pie charts are typically circular and sliced into pieces that represent different categories. One thing that I want the students to remember that if you add up all the percentages of all categories in the pie, you will get a unit of 1 because this is one whole piece, right? You cut small portions to represent different categories. You add everything up, that should give you 1. So we can test this out. 48%, as we learned, divided by 100, this is 0.48, right? And add the second term, 0.12, third term, 0.26, 0.08, last term 0.06. That should give you a unit of 1. The student should check this one out. That's one thing. 2, we can look at this pie chart problem in the following way. If you have 100 people to choose from all the categories, and then there will be 48 of those choosing the prickle. Why is that? If I have 100 total people, right, the percentage is 48 that will choose this kind. 100 multiply 48% give you 48. So there will be 48 choosing this one. And similarly, there will be, if you have 100 people total, you will have 12 people choosing the lint type. And this problem asks us for 36 of the members choose cat hair pie, which has an 8%. If I have 100 people, right, there will be 8 people choosing the cat hair. Now I need 36. So 36 divided by 8, that's 4.5 times. So therefore, I need 4.5 times of 100 people, which is 450 people total, to give me 36 that choose the cat hair type. So now we know the total. We need to find the final answer. How many of those will choose a sawdust pie? So 450 total. Percentage for sawdust is 26. Is 450 multiply 0.26. And we'll let the students figure out the final answer.